morning. Today we will be learning about character sets and variables, and it will be the second lecture of this series. So, let's start with this. So, the first thing we will be learning is character set. What is a character set? It is a very important part when we are writing a program in Python, because if we don't have a proper knowledge about the character set, we can't even write the code properly without any error. So a character set is a complete structural collection of valid letters, digits, symbols, and spaces that Python natively recognizes during execution. So in simple words, it's a group of valid letters, symbols, digits, and etc., which can be used in our code in Python, without which Python doesn't raise errors. Such as there is an example given here. If we say it, the first one is fully legal syntax. In this, see, we have print hello. Just like we have learned in the previous lecture, it is fully correct. There is no error in this. But when in this example we are writing print, then we are using this character here, then hello. This is an illegal character. This is not in the character set. So it will raise an syntax error. It is an error, and as we have used an character which is out of the character set, it will raise an error. Say here there is given a syntax rule. Using characters outside their legal contextual boundaries forces Python to instantly drop execution and raise syntax error. That's what I just told. If we use something or some characters which are outside the character set or the collection of the valid characters which are not legal, Python instantly drops the execution and raises an syntax error. So we will uh, then comes the anatomy of Python's character set. First is the alphabet. We all know we have to use alphabets, or otherwise we won't be able to write codes. Alphabets, all uppercases and lowercase letters, case sensitive, makes them fundamentally distinct. All the uppercase and lowercase letters are in the character set, that is, they are legal characters which can be used in our program. But we have to keep in mind Python is case sensitive, so we can only use so we can only use um, this thing correctly. Like in print, we cannot write P capital, it has to be small. Everything has to be case sensitive, otherwise it will give errors and it will not run. Second comes the digit. Standard numeric base token ranging from 0 through 9, used directly for functional evaluations. So digits 0 to 9, combinations of them, infinite number we can make through it, all are approved in the character set. Third is the special symbols. You have to see this properly, because not every special symbols are legal in the character set. So operational tokens including mathematical operators, bracket blinds, punctuation and markers such as plus, asterisk, hash or at the rate are legal tokens which can be used. White spaces, blank layout characters including standard spaces, horizontal tabs, and new line termination. So all these are acceptable, and we will be learning more about this in further slides. So character encoding standards. Imagine comparing ASCII and Unicode characters support ranges mapping simple English character versus global text symbols. Legacy ASCII standards. Let's talk about the ASCII standards, that is the legacy mapping. Limited structural range supporting 120 traditional characters covering baseline English and common punctuation metrics. It's very much we do in English. The ASCII, we all know about the ASCII. It is the numbering or the value given to each and every English alphabet. So it talks about that only. And here is the Unicode standard native Python default. This is the native Python default we used earlier. Universal infrastructure enabling seamless processing of global alphabets, complex regional text layouts, and diverse graphical iconography natively. Next is the role of structural indentation. Indentation is very important when we come to Python. Without indentation, the loops are meaningless, because when we start when we'll be learning about loops, we'll come to know when we start a loop, the work done should be inside the loop, and that has to be maintained using indentations. So it is a very important part. Whitespace as logic. Unlike languages utilizing strict curly braces to map execution boundaries, Python mandates whitespace structure to construct programmatic blocks. Improper spacing scales cause intermediate operational blocks via indentation errors. So when we code in languages such as C or C++, we for showing or constructing programmatic blocks, we use just curly braces. But in Python, we don't use such things. We just use simple white spaces, single white space in uh, single white space for loops, double for nested loops, and everything. We will learning this further. If the spacing is improper, then Python immediately drops the operation and raises an indentation error. So there are many types of error, and we have to note it down, because if we can be given question where we have to identify the what kind of error this is. See, such as here is an example. If age greater than equal to 18, then we have given a single white space gap here, which can which automatically comes after the semicolon when we press enter. This is the indentation required for an conditional statement or if else statement. Here indentation, then print eligible to vote, print process complete. This shows that if the age is greater than 18, then this will be printed here. It's that simple. Yes. Understanding variables. This is the topic number 5, I think. Here we will be understanding about the variables which are very important. The data containers. What are data containers? It's simply the variables or the data containers are the spaces where we store a value or store a string or data. A very Here it is written, a variable is an explicitly named allocated reference block inside system memory tasked with retaining modular data points whose values fluctuate over runtime life cycles. Simple example of a variable is this: age equal to 20. Age is a container data container or a variable which is blank when created. But here, when we use that as age equal to 20, that means the value 20 is being stored in that age variable. And when we use this print age, then actually this prints what is this prints 20. So it is written here, rather than continually hard coding changing primitives, variables provide abstract logical tracking. And this is same thing that I just explained here. Then comes memory allocation behind the scenes. Behind every step we do, everything we store, every print statement, there is a memory allocation. When we are giving age equal to 20, a memory is being allocated where the 20 is stored. This happens in the backend, but we should have a basic knowledge about this. Imagine image demonstrating dynamic memory pointers where variable tags attached to actual object memory addresses inside the system RAM. Here, step 1 allocation, such as age is 19. Here, it is stored in one memory. Then, step 2 mutation, age equal to 20. If we changes the value of it, the memory allocation is also different. These two doesn't have the same memory allocation. When a variable value is modified, Python's level rebinds to point at the updated numeric object content. That's what I just said. Variable constructual configuration rules. There are some rules we should follow. That is fully valid layouts. Student name, snake case, and strictly prohibited is like we cannot use digits in front of our variable. It is illegal. We can't write two students. We can write student 2, which is good. We cannot start the name of a variable with a digit. It has to be in snake case. Then this is a valid one, dash underscore roll number, underscore can be leading, can be trailing 2, but the student dash name cannot happen. Contains operator hyphens. This is illegal. Here marks underscore 95. I just said trailing can also be there. Trailing underscore and trailing numeric markers or digit is allowed, but here this is again illegal as student whitespace name. When we do empty spaces, it doesn't Python doesn't treat this as a whole variable, so it becomes illegal. Simple price, simple lowercase, it is accepted and it is legal. Class slash for the class or for this cannot be written. These are keywords, reserved keywords. These are actual functions. This has functions. They do certain works. They can't be written as variables. Reserved keywords can't be written as variables. This has to be very clear. This is a place where everyone makes mistakes. Crucial role code must exclusively begin with an alphabet letter or a leading underscore. Variable name must start with an alphabet letter or a leading underscore, and it can't start with a digit. This has to be kept in mind. Then comes can never contains functional space or operational mathematical expressions. Third is cannot hijack reserved structural core keywords such as class, for, if, and etc. Next is advanced allocation parallelisms, multiple context target assignments. such as it is not bound to us that we have to assign like a equal to 10, then b equal to 20, again c equal to 30. We can assign all the three values to the three variable respectively in a single line, like a comma b comma c equal to 10 comma 20 comma 30. In this, 10 is being stored in a, 20 is being stored in b, and 30 is being stored in c. In this gets stored in a serial wise. Bind distinct random primitives to a matrix of parallel variables inside a single expression pipeline. This forms a pipeline in which data are stored in a parallel way. Chained single value binding. Think such as we have to store a single value but in three variables, such as x has the value 20, y also has the value 20, and z also has the value 20 or 20. Then we can do it in a single line, like x equal to y equal to z equal to 20. That means x is also 20, y is also 20, and z is also 20. These all things can be written in one line. Actually, by doing this multiple context target assignment or chain single value binding assignment, what we do is making our codes short, which is very important when we'll be learning in DSA time complexity. It helps a lot when we are reducing the three-line code to a single-line code. It helps in time complexity. It makes our program better. Variable swapping mechanism. This is also very important. In later programming, we will be learning about swap case programs also. Swapping using third variable. This is an example of swapping using third variable. Then there is also one program that is a bit tougher, that is swap use without third variable, where we can't use this temp variable, we have to swap it without this extra variable. So here is the traditional overhead method. Requires provisional a temporary intermediate variable bucket buffer to preserve pointers without overwriting raw data values, such as we have to swapping means there is a value assigned to a variable a and a value assigned to variable b. We have to exchange the values, means the value stored in variable a must be stored in b and the value stored in b must be stored in a. We have to exchange the values. So it's very simple. We will take a third variable and store the value of a in the third variable. The third variable is a empty container. We will store the first value of a in the third variable. Then we will overwrite the uh, variable a by assigning it the value of variable b. Now the value of variable e is equal to the value of variable b. Now we will override the value of variable b by assigning it to the value of variable temp, which actually was the value of a. So when the result will come, this is something like the value of a has been given, the value of a is the value of b and the value of b is the value of a. So the swapping is done. Second is the Python's clean shorthand engine. executes automatic clean parallel variable substitution without necessity any auxiliary memory tracking variables. When coding in Python, it is very easy and we don't have to do anything. If we write a comma b equal to b comma a, it simply swaps the value. Like when we are assigning a comma b to b comma a, then the value of b assigns to a and the value of a gets assigned to b, and in a single line we complete the swapping. Variable destruction via del. So let's see what the variable destruction via del says. Explicitly binding severance. The del statement severs the connection between a variable name and its memory allocation block immediately. Any subsequent lookup request on the token argument throws a name error as it ceases to exist. So we have here we stored created a variable x where we stored the value 100. Then we did del x. Does del x do? It deletes the variable from its memory allocation block immediately. That means we created the variable x, assigned the value 100 in it, then when we do del x, it actually deletes the variable x along with its value from the memory itself immediately. And as a result, when we print x, there is no variable named x stored in the memory, as this step deletes it. And actually, so as a result, this ends in a name error. Python throws a name error as x variable is not in the memory. Critical pitfalls and mistakes. Here we will be learning about the faults we do mainly, or the critical mistakes we do, such as word processing codes, copying code snippets out of text documents. Like Word can introduce style smart codes, bringing string parentheses, token operational mix-up, confusing individual equal assigns with comparison value double equal to inside processing state. This is very important. When we write a equal to 10, or a when we write a equal to 10, or b, that means we are assigning the value of b, or assigning the 10 value to a. But when we write a equal to double equal to b, that doesn't mean a is the value of b is being assigned to a. When there is a single equal to, that means value is being assigned to a. But when there is a double equal to, that means a the value of a and b is being compared. Here double equal to simply means it's a comparison is happening between the two variables, and the result comes out in binary, in 1 and 0 format. The structural space inclusion accidental a leaving empty character breaks inside identifiers structural XML compiler scans instantly. Introduction to variables. The bank locker analogy. Every bank locker has a unique level number protecting valuable resource inside. Instead of memorizing raw hardware coordinates in memory, applicants assign clean human readable levels. Without variables, managing real-time features on apps like Instagram, WhatsApp, or ChatGPT would be functionally impossible. So we already learned about what variables are and how they are stored. And it's simple. Without, if variables wouldn't be in existence, then we couldn't do anything. Actually, without variables, programming is functionally impossible. Here are some of the examples given: locker one, money, variable, variables, and etc. What is a variable? A variable is an identifier that references a dedicated memory address allocated to store object values during program execution. What is a variable? Variable is a container with a dedicated memory address allocated where we store the value, string, or anything during a program which has a proper scope and existence. Here is an example given about what variable actually is. This name is a valid variable where we are storing this string opine. String must be wrapped in quotations. Remember it always. Then age equal to 19. This is also given. Here CGPA is equal to 7.83. This all values 7.83 then 19 all are getting stored in the variable named a, CGPA name, and etc. Why do we need variables? It's very important. Many of you, while learning, a question may have arrived. We are learning what variable is, everything is okay, but why we need it? The hard-coded, inefficient. Modifying a value force manually edits on every isolated code. There can be two processes: print, open, print again, open, print again, open. This is slower. This has to be managed in every step, but this is not in case when we use variable bound. It is scalable. Update a single baseline assignment to change data instantly. We are creating a variable name equal to, we are assigning the value pan, and the number of times we need to print, we are just printing that name, not pan. So now the container analogy. For beginner orientation, envisioning variables as standard hardware storage content is structurally helpful. That means it's telling the same thing, that for beginners, think variable as an empty container or storage container where we store things, such as in real world example, a bottle container. It holds water. Same as that, variable name container hold values. This variable can be very much equal to the water bottles we use in college. Simple. Real memory representation. Image showing dynamic memory pointer mapping through an active variable reference memory slot containing an integer type object shifting down cleanly a data mutates. Initial allocation age is equal to 19. Value reassignment age equal to 20. When age transition to a point at 20, the unreferenced value 19 is automatically orphaned and subsequently swept from the RAM by the Python's backend tracking management. That means first when we assign the value 19 to the variable age and the value 20 to the variable age. When initial allocation happens, a memory is allocated to the age value where the value 19 is being stored. But when we reassign, the memory location also reassigns. This can be better understood when we will be learning about pointers. So here variable declaration comparison. Statistically typed C and Java, data containers must declare explicitly binding data types limitation ahead of runtime allocation. Integer age equal to 19, float marks equal to 95.5. We in C and Java we have to explicitly uh, tell the compiler that the variable age will store integer type or marks will store float type. But in Python, it happens dynamically typed. Python, no explicit ahead of time typing declaration needed. Python contextually refers type bounds from runtime object assignment values. That is age equal to 19, name equal to Rahul. It, when we store the value in that variable, it automatically gets what we are storing. We don't have to indicate or tell him that this is the variable name or anything. So then comes the syntax of variables. Variable name equal to value. This is the syntax we already talked about. Left side is the token pointer token identifier, and right side is the instant object data matrix. This is the name which will be stored in the memory allocation, which can be used as a pointer in further things, and this is the value that has to be stored. The equal character strictly as an assignment operator. The equal to is acts simply as an assignment operator, not a mathematical declaration of balance or equal to. This is an example. Say it properly. Name equal to Payan, age equal to 19, price equal to 299, is student equal to true. These are the types which are legal and are accepted. Here is assignment equal to versus comparison double equal to. As I already said, equal to means getting a value is being assigned to the variable, and when there is a double equal to, that means the value of the two variable is being compared. Here equal to assignment operator stores the evaluated expression value from right hand boundary to the targeted left hand identifier reference location. That is, the 20 value is being stored in the variable named age. This binds reference value, does not compare or represent mathematical equal to. It only means assignment operator. Double equal to comparison equation evaluates binary logic identity parity checking between left and right structures, instantly resolving down to true and false. Age equal 20. This checks if this is true or false. This only compares. No allocation is happens here. Now creating multiple variables. Parallel structure and unpacking binds multiple separate primitive expression down to unique relative tracking if lines from a comma b comma c equal to this, but I already talked about. This is the multi chain token pipeline. These are also the names. By how we have to unpack this is also the thing we have to learn. These are the same things we already talked about. Here are some quiz we should be practicing, which take a minute pause and check how you are doing this. Which represents a valid variable token identifier assignment configuration. First is to age and option B is student age. Here numbering is a problem. So try to understand first, then we will be discussing about this. So here the nine. So here the answer will be student age. It is very similar, as I already said that to age is not an option, because name of a variable cannot start with digit. It always have to start with alphabet. So C is the correct answer. See, yes, here a syntax error tracker is given. 19 equal to age. It is a syntax error because the variable name must be in the left hand side and the value must be in right hand side. Student name equal to capital X. This is also a syntax error because white space between a variable is not legal. Variable name rulings. We already did this. All part we have already did. Take a look again that every identifier reference tag must definitely begin sequence using an alphabet character A to Z or small a to Z, or an explicitly leading underscore character. Leading off names directly with numeric digits throws an incident architectural processing can crash. White space and character constants. No blank spaces are allowed while naming a variable. Whitespace terminates and identifiers can use snake underscore to bind multi-word identifiers safely. This is an illegal because student whitespace name equal to Rahul is given. This terminates the variable name. But when we use student underscore name equal to Rahul, this is legal, as we are using two words in a single word. Special characters forbidden. Symbols like all this percentage hash and carry executional logic and cannot form name segments. Student omega name equal to Rahul. This is illegal. Marks percentage equal to 95. This is also illegal. Python is case sensitive. In previous lecture we already talked about this, that Python is very much case sensitive. Case variation fundamentally shifts architectural targets tracking path inside system RAM because Python treats case explicitly. Changing a single character frame allocates a single new standalone identifier reference handle. See here, small in lowercase age is written and 19 value is being assigned to it. Here capital A and small ge is age is written and 20 is being assigned to it. Here capital age is written and 21 is assigned to it. These three variables are separate variables, and this has different memory allocation. This has different, this is different because it is case sensitive. Even one alphabet is in different case, this is a makes it a different variable. So when we print small age, it gives 19 only. Reserved core keywords. These are some of the keywords which are being reserved and cannot be used for naming a variable. Python contains a specialized matrix of internal keywords dedicated executively to steering core engine operation, condition workflows, or class setups. Attempting to assign variables configuration onto these keywords through an immediate execution have failed. So these are the reserved matrix or the keywords which cannot be used for naming in a variable such as if, else, for, while, break, class, true, for, return, false. This cannot be used for naming a variable. The value of meaningful names. It is very important to give a meaningful name, because when we give a meaningful name, a idea about the what the value represent is given to the user or the person who is seeing the um, or reading the code. Poor readability. Giving a bad naming makes a poor readability for the user. Obscure shorthand forces readers to exhaust cycles guessing architectural context path. A equal to 100, B equal to 200, C equal to A plus B. We don't understand what this A represents or B represents or C represents. But when we write it in a proper naming, enterprise standards, self-documenting layout states operation context clean to engineers instantly, such as price equal to 100, GST equal to 200, total price equal to price plus GST. Here we know this 100 value represents the price, 200 means GST, and the total price means price plus GST. This is much better. So here we will be stopping our today's lecture. So thank you everybody for listening and seeing this. We'll be coming back tomorrow again with something new, and by then if you have any doubt, please leave in the comments.